All right, let's start this week by talking about how you enhance sounds. How do you make a sound really stand out from the mix, and how do you give it a more clearly defined sound from other parts? Well, on their own, many recorded or synthesized sounds are okay, but they're only okay. Samples tend to have issues with volume, EQ, noise, and if they were recorded off axis. And that last one you cannot fix, you just have to record it again. Synthesized sounds tend to be a little bit on the thin side, or to require some additional type of development of the timbre or the modulation to make it sound more human or realistic. So things like adding a slight delay and reverb are so common that they're built into a lot of modular systems. And it's very, very common to record the synth through an amp in an actual room to let the sound develop, to get some of that room reverb in there, even if you're just playing the synth through MIDI. Another common technique is using gates. These are exceptionally useful to remove ambient noise from the room, from a fan, ground hum, anything like that from the silent portions of a track. The noise will still be present when the sound that you were actually trying to hear is playing, but hopefully it will be masked by that sound. If it's not, you can always go to a noise reduction plugin. Isotope RX and Refer, which is built into Reaper, are very, very common. They work by using spectrum analysis of a noise signal from the recording to learn the noise. Then it removes that from the signal. It's very effective for clearly defined noises in very small degrees. If you use too much, it will remove other parts of the signal. It will start to sound underwater. It will lose parts of the fundamental. It can be a cool effect, but it's usually not, and usually it destroys more than you want. Another classic technique is equalization. The old standby. Get rid of frequency areas that aren't in the range of the signal you're working with. So if I'm working on a violin, I'm going to cut out just about everything below 200 hertz in order to avoid instrumental bleed or any type of ground sound. Then you can always boost frequency areas that help to define the timbre of the instrument or the sound that you're recording. But again, small adjustments are better. Don't take anything up to plus 32 dB or anything ridiculous like that. And be wary of the ranges that you're mixing the EQ in. So you've got the sub bass, which is anything less than 40 hertz, which is barely audible, not directional sound. The bass range of 40 to 100 hertz, which is where most of your bass boosting will actually occur. Then you have the low mids of 100 to 800 hertz, which is where most fundamentals for various instruments other than the bass will occur. The mid-range of 800 to 5000 hertz, which is where a lot of the harmonics can be brought out and add more body to the sound. The highs in the 5 to 8K range, that's your treble boost. That adds brightness and presence. And then anything above 8 kilohertz is going to be the upper harmonics of instruments and cymbals and adds just a little bit of that indefinable sparkle to a sound. Do not forget about panning either. It's essential to place the sound in an individual location to keep the mix clear and avoid EQ issues. So you can generally position all of your sound sources left to right within a signal. You can spread them out using stereo spread or width, depending on the program, to get an area of effect. I know some of you are Dungeons & Dragons players, but yeah, the area of effect is you're defining a range where that sound will be heard. So what is the outer leftmost section? What is the outer rightmost section? And then everything between those, the signal will be attenuated and centered between those 2 points. You can move positions through automation or via LFO to control the position. Delay is another way to really add some depth to things. Just a slight delay of 1 to 30 milliseconds will fatten the signal when panned opposite the original. This is a great effect to use on a synth or a thin sounding recording in general. Then, of course, there is reverb. I recommend putting it on a bus and using the sends to apply the effect to all signals, because different reverb on different tracks sounds bad. This is why whenever I am recording a band, when the guitarist is like, oh, I want to have the reverb on my guitar, I am fine with them doing that if it's on a send, but if they're putting a weird reverb pedal on their guitar, there are problems, because typically then it ends up like the guitar is sounding washed out when I then, record them in a hall. So do not use different reverbs on different things. Use the same reverb and use different amounts of send to push things back in the mix. And to really push things back, up the send level and decrease the volume, and it will accentuate the effect. You can also use convolution reverb, which uses impulse responses to emulate an acoustic space mathematically. This is super convincing. It is really, really well done in all of these programs. In Ableton Live Suite, you have convolution reverb. In Logic, you have Space Designer, and in Reaper, you have Reverb. And all of those take impulse responses, so you can download additional impulse responses from OpenAir and at the Reaper blog. But again, use it to enhance, not obliterate sounds, unless you're doing that for a very specific reason. There are also CRAZIER enhancements for sound design for acousmatic music, film or game effects, or other sound design tasks. Things like layering and crossfading multiple sounds, which creates interesting hybrids that you can then bounce down because they've got a lot of sonic interest. And then you can put those into a DAW and use DAW tools to sample them, to rearrange them, do cool things with them. Doing this requires attention to detail, though. Specifically, where and how you fade between the sounds. And then you can also combine this with time stretching and transposition of pitch. Doing that, it's a nearly infinite way of generating material. And again, all of that can be bounced down and put into a sampler as an instrument. And please note that by editing your sounds and manipulating and mixing them yourself, you have a better idea of how they will have to fit in the final session. You have a more intimate knowledge of their sonic characteristics. If it's more biased towards the treble or the bass or the mids, if it is something that is dynamic and moving and panning from left to right or right to left, or if it's just a mono stay wherever I put you type sound source. Samplers, great tool. We talked about last year. They automatically transpose across a range of keys for you, which is extremely useful even if you just want one or two specific transpositions. You can also use velocity layers to create splits, or use different layers like key, velocity, or mod wheel to fade between different samples. This works extremely well. You can create some really cool morphs doing that, record them, and then bounce them and put them in another sampler. You can also map out slight variations of the same sound to different layers to get a really humanized feel. Say if you do different attacks to get those mapped out to different velocities. Bit crushing, one of my personal favorites. It reduces the sample rate of a signal to give it that classic 8-bit sound. Remember, though, that you are reducing the sample rate. If you are reducing the bit depth, what happens? You crush the volume. And eventually, you will get down to a bit depth of 1, which is either full on or full off. Nothing in between, and it is going to be screamingly loud. So be careful, reduce the sample rate, watch out for the bit depth, maybe don't use it. Ring modulation, this is a particular favorite of mine for anything sci-fi. It modulates a signal by a static frequency, deliberately creating the metallic sounding sidebands on either side. Apple's ring shifter in Logic Pro is wonderful for this. Spectral convolution. This takes the pitch or volume of one signal and applies the spectral components to another. So you're taking the pitch of one thing and the timbre of another, cross-multiplying those. So think of it like creating a person that speaks in the timbre of a cat meowing. It is super easy to do in Max MSP or PD and then render this to a new file. If you want to learn how to do it, just set up a time with me and I will go over how to do it. Finally, you can decompose sounds and resynthesize them in programs like Spear or in Flucoma or Recoma. And we will get to that momentarily, and you're going to have a lot of fun with those. But while we're looking at how to deconstruct these, how to enhance these, we need to analyze the sounds as well. What are you hearing in the sound? Your ears are key. So listen closely to an interesting sound and think about what makes it. What do you hear? What do you hear when you change the EQ, the volume, the panning, the effects, layers? How do these contribute to the sound? Can you identify the individual components needed to reproduce a sound, if it's a hybrid of 2 samples or more? Then what are the frequency components of the sound? So all DAWs have at least a basic spectrum analyzer, and you can always download Blue Cat's free pack as well. Earcam's TS2 is also really great for the sonogram view if you really want something that goes into a little bit more detail. Taking a look at that, what does that reveal about the overtones in a sound if you're looking at the spectrogram or the sonogram? Are there obvious breaks in the time domain or in the frequency components? Are you losing everything above 5K? Or does it look like you have obvious breaks in the sound file that have been spliced together? Compare that to your ideas of the components of the sound. Can you come up with a map that would be a pretty good way to reproduce this sound?